Okay, so I scavenged some mollusks from the dissection specimens over at the high school before, when we got a chance to go back into the room for a little while. And so I'm going to do some demonstration dissections. I know we would have preferred to have this be you doing your own dissections, but it is what it is. I'm out in the backyard. You can hear birds chirping in the background. Turtles are sitting over in their pool, and I got some snails. I got some freshwater mussels, and let's see if I can move this. I've got some squid over here, which I didn't get a very good view of that there for you because I got to loosen this up. Sorry about the camera issues. There we go. So let's take a look first at snails. Well, I guess first thing we want to do is we want to recognize that you got four main categories of mollusks. You got your chitons, which are the most primitive form, and sadly I forgot to grab the jar of chitons, so I can't demonstrate that. I can show pictures of them on PowerPoints and stuff like that, but I'm not going to be able to show you a chiton directly. Gastropods, which are slugs and snails, and you can see I've got a couple of snails here. This is a terrestrial snail called Helix. And we have some freshwater mussels, as you might find in say Lake Michigan and other Great Lakes region. So we're going to look at them internally, and then I've got the squid over here, and I've got actually two of them. One of them is a real big one, so we're going to have to do some adjusting of the camera to be able to get that all on camera. Now, first of all, body form. Remember, you got your visceral mass, which is the guts, and the guts include all of the internal organs, the digestive system, the reproductive system, the gills. And the gills, if it has gills, are going to be covered by the mantle. And the mantle, in some cases, secretes the shell, and in other cases does not. Obviously, in the snails, they have a shell. In the mussel, they have a shell. The squid do not have a shell. Now, there are some kinds of squid that do have a shell, called nautilus. I don't have any nautilus to show you. Back at school in the display case, I've got some fossilized nautilus shells, and I've got some actual nautilus shells, but they're not available to me right now, so I'm not going to be able to do that. And so you got your visceral mass and your mantle. The mantle secretes the shell, and the mantle covers the mantle cavity where the gills are located. And then you have your head foot. Now, in the case of your mussels, there isn't so much a head. There's not much cephalization in the bivalves, the class Pelecypoda. But the snails are highly cephalized, and the cephalopods, the squid and the octopus, are also highly cephalized. All right, so the chiton, not so much. The chiton is, like I said, a very primitive form. So we're going to look at the anatomy of these three types. And to begin with, because it's the simplest to look at, we're going to look at the freshwater mussel. Now, the mussel is, and it's not muscle like your biceps or the muscles of your body. It's mussel, and the mussel is a kind of clam. It is a bivalve. It has two shells that are hinged. There's a hinged ligament back here. There's a little raised area that's the primitive embryonic shell called the umbo. And then if you look at the shell, you can't really see it in the video, I'm sure, but you can look at diagrams. Maybe this one's dried out so you can see it better. You can see that there are lines, which are growth rings, much like you'd see in a tree. Every year, there are some seasons where food is plentiful, and then in the wintertime, food becomes less plentiful. And so they have a rapid growth period of time, and then slow growth, and then rapid growth again, and that creates ridges. And you can find the age of the clam that way. I'm not going to spend any time doing that right now, but you can. Now, the shell has a hinge ligament on the back, and that ligament is going to create tension on the two valves. So when that ligament becomes stretched, it's elastic, and when it would snap back, it would open the shell. So the action of the hinge ligament would open the shell. There are two large muscles. This time we are talking about muscles like muscular system. one in the front and one in the back, anterior and posterior adductor muscles, that when they contract, they pull the shell closed. So what I'm going to have to do to open this shell is I'm going to have to work the scalpel in here a little bit, and I'm going to cut the adductor muscle. Sorry for moving my hand in front of the camera. And I'm going to cut this adductor muscle. Should have grabbed the sharper scalpel blade. And hopefully that'll allow me to open up the shell. And when I open up the shell, I'm going to use my blunt probe. The blunt probe is your best tool in dissection. I'm going to separate the mantle away from the edge of the shell, and I'll open the shell up and set the shell so that I'll actually break it in two. So I'm going to move that piece of the shell out of the way, and now you have the body of the clam. Now down over on this side, scraped away, I have the, let's see, that would be the posterior adductor muscle. And over here I have the anterior adductor muscle. And here is the mantle. Okay, the mantle is a flap of skin. It's very thin in this animal because it's secreted the shell, but other than that, it just covers the gills. When I lay the mantle back, you see the gills. They're feathery and have a lot of surface area, so now I'm using the probe to lift up the gills. And there's two flaps of gills on this side. And there we go, separate them a little bit, tore it accidentally, but there's gills. Over here you have the visceral mass of the animal, and you have the muscular foot. Now, the way this animal feeds, it's a filter feeder. There are two siphons over here, one where water comes in. This is the in-current siphon, and it'll circulate around the gills, and then the ex-current siphon, water will come out. And when water comes in, the water circulates and provides oxygen for the animal that'll be absorbed by the gills, and then you also have food will come in tiny little particles that will stick to mucus strands on the gills, and they'll move forward to the mouth. So you have your anterior and your posterior, and here's the muscular foot. You have your in-current siphon and your ex-current siphon. It's difficult to see from where you're looking, but the muscular foot, you can see sort of a little line here where the muscular part of it is separated from the guts, the visceral part of it, and you can feel and see the texture difference here, but it's difficult to show on camera. Got a lot of fluid in here, so I'm going to get rid of the fluid. Dump it back into the bucket. All right. So there's the body of the clam, muscular foot, visceral mass, gills on both sides, in-current siphon and ex-current siphon. The mantle covers the gills and secretes the shell. You can see the shell here. The inside of the shell has a scar from where let's see, that would be the, I don't remember whether it's anterior or posterior here, but there would be a scar where one of the muscles was attached and a scar where the other muscle was attached to the shell, and they would pull the shell closed. The hinge ligament keeps the shell open. And for the sake of keeping this fairly simple, I'm not going to do too much inside of the animal. These particular animals, there's not much to see inside, but one thing that's worth seeing is that they have an open circulatory system. Now, what you won't really be able to see that, but it's worth bringing up. They have a body cavity. Okay, they have a true body cavity. They're schizocoelous, and that body cavity is the result of the mesoderm splitting into two parts, leaving space in the middle during embryonic development. Okay. Now, for us, going back to circulatory system now, for us, we have a closed circulatory system, which means our blood is always in blood vessels. Okay, it's in our heart, then it's in arteries, then it's in capillaries, then it's in veins, then it's back in our heart again. Fluids leak in and out, but the blood cells stay in. Okay. Materials can be absorbed, materials can be given off, but the blood itself stays inside the blood vessels. These things are different. They have an open circulatory system. And in an open circulatory system, what you got is the body cavity is full of blood. And it nourishes all of the organs, all of the internal organs from the outside. Okay, for us, Blood vessels bring blood into the liver. Blood vessels bring blood into a muscle. So our organs are nourished from within. Your muscles are nourished by soaking in blood that fills the body cavity, which is very, very different from our own. So they have an open circulatory system. Ours is closed. Now I'm going to take the scalpel here, and I'm going to, still got a lot of fluid. I'm going to take my scalpel, and I'm going to make a little incision here. Boy, I should have gotten a better scalpel blade. This is terrible. I got a little opening started, and now I'm going to switch to scissors because scissors work better. With scissors, you don't accidentally cut what's underneath. And I'm going to make an incision along the edge of where the visceral mass meets the muscular foot. And then I'm going to run my probe underneath there, and I'm going to lift that away and separate from the material that's inside. I hate these gloves. And when I do, you can take a look at what's inside. Now, there's not a whole lot to see. Okay? There's not a whole lot to see, but as I look at it, I can see, for example, I can see a little tube here. I'll try and clean it up. That little tube would be the intestine. So there's the intestine. And so the visceral mass contains the internal organs for digestion and reproduction. There's not a whole lot that we're going to really look for there, but I just wanted to take a look inside. Here in the body cavity, it would be filled with blood because they have an open circulatory system. Okay? And the organs would be nourished from the outside. Muscular foot is hatchet-shaped. If you look at it, it's sort of like a hatchet blade. Okay, the Greek word for hatchet is pelecypo, so these are pelecypods, hatchet foot. Inside the mantle cavity, you have gills, which are for absorbing oxygen and getting rid of carbon dioxide. That's called gas exchange. And also, they make mucus strands that are going to collect food that is particulate from the water, so they are filter feeders. And the mantle not only covers the gills, but secretes the shell.